Moving on to the first question. Evaluate in the first bit sin 18 by cos 72. So let us find the solution for the first bit. The given expression is sin 18 degrees by cos 72 degrees. Let us express both numerator and denominator in the same trigonometric ratio. We have sin of 19 minus a is equal to cos a, and cos of 90 minus a is equal to sin a. By using these two identities, let us convert both numerator and denominator into single trigonometric ratio, either sin or cos. So as we have in the numerator sin 18 degrees divided by, let us convert the denominator cos 72 degrees in terms of sines. That will be sin of 90 degrees minus 72 degrees, which is equal to, in the numerator sin 18 degrees remains as it is, divided by sin of 90 degrees minus 72 degrees is nothing but 18 degrees. As here numerator and denominator is common, sin 18 degrees by sin 18 degrees will be equal to 1. Now moving on to the solution for second bit. The given expression is tan 26 degrees by cot 64 degrees. To solve this, let us convert both numerator and denominator into single trigonometric ratio, that may be into tan. We have cot of 90 degrees minus a is equal to tan a, and tan of 90 degrees minus a is equal to cot a. So let us convert the numerator and denominator in terms of tan. So numerator is already in terms of tan, that is tan 26 degrees by cot 64 can be written as tan of 90 degrees minus 64 degrees, which is equal to, numerator remains as it is, that is tan 26 degrees divided by tan of 90 degrees minus 64 degrees is nothing but 26 degrees. As here numerator and denominator are same, tan 26 degrees by tan 26 degrees will be equal to 1. Now moving on to the solution for third bit. The given expression is cos 48 degrees minus sin 42 degrees. Here one term is in terms of cos and other term is in the terms of sin. So let us convert this into a similar trigonometric ratio, either sin or cos, by using the following formulas. That is, sin of 90 degrees minus a is equal to cos a, or cos of 90 degrees minus a is equal to sin a. So let us convert this cos into sin. That will be sin of 90 degrees minus 48 degrees minus sin 42 degrees. This will be equal to sin of 90 degrees minus 48 degrees is nothing but 42 degrees minus sin 42 degrees. Now sin 42 degrees minus sin 42 degrees is nothing but 0. That is the solution. Now moving on to the fourth bit solution. The given expression is cosecant 31 degrees minus secant 59 degrees. Now let us express the given expression in terms of either cosecant or secant by using the relations that cosecant 90 degrees minus a is equal to secant a, or secant of 90 degrees minus a is equal to cosecant of a. So Now let us convert this cosecant 31 degrees minus secant 59 degrees into secant. That is, cosecant 31 degrees can be written as secant of 90 degrees minus 31 degrees whole minus secant 59 degrees, which will be equal to secant of 90 degrees minus 31 degrees is nothing but 59 degrees whole minus secant of 59 degrees. Now secant 59 degrees minus secant 59 degrees is nothing but 0. Moving on to the second question. Show that problem number 1, that is tan 48 degrees into tan 23 degrees into tan 42 degrees into tan 67 degrees is equal to 1. Now moving on to the solution. For the first bit, we have to prove that tan 48 degrees into tan 23 degrees into tan 42 degrees into tan 67 degrees is equal to 1. Now let us consider only LHS in this. That will be tan 48 degrees into tan 23 degrees into tan 42 degrees into tan 67 degrees. Now in this, let us consider tan 48 degrees into tan 42 degrees together and tan 23 degrees and tan 67 degrees together. Here these are in the form of tan A into tan B, in which A plus B is equal to 90 degrees. In A plus B is equal to 90 degrees, let us make subject as A by sending B to the right hand side. Then it becomes A is equal to 90 degrees minus A. Now applying tan on both sides, we get tan A is equal to tan of 90 degrees minus B, which implies tan A is equal to tan of 90 degrees minus B is nothing but cot B, which implies tan A is equal to cot B can be written as 1 by tan B, which implies now by transposing 1 by tan B to left hand side, we get tan A into tan B is equal to 1. When A plus B is equal to 90 degrees, then tan A into tan B is equal to 1. Similarly, if we observe here, 48 degrees plus 42 degrees is equal to 90 degrees and 23 degrees plus 67 degrees is equal to 90 degrees. So this is in the form of tan A into tan B, where A plus B is equal to 90 degrees. So by using this derivation, we can say tan 48 degrees into tan 23 degrees into tan 42 degrees into tan 67 degrees, which is equal to tan 48 degrees into tan 42 degrees, which we wrote it together, into tan 23 degrees into tan 67 degrees, which will be equal to, this whole value will be equal to 1 from the above derivation, and this whole value will be equal to 1 from above derivation. And now 1 into 1 is nothing but 1, which is nothing but the right hand side of our given equation. Therefore tan 48 degrees into tan 23 degrees into tan 42 degrees into tan 67 degrees is equal to 1. Moving on to second bit of the second problem solution. Here he asked us to prove that cos 38 degrees into cos 52 degrees minus sin 38 degrees into sine 52 degrees is equal to 0. In order to prove this, let us consider first the left hand side, that is cos 38 degrees into cos 52 degrees minus sine 38 degrees into sine 52 degrees. Now here if we observe, the one term is in terms of cos and other term is in terms of sine. So let us convert the whole expression in terms of sine, so that makes us the expression simplified. So this can be made by using the following formulas, that cos of 90 minus a is equal to sin a, and sin of 90 minus a is equal to cos a. So now let us convert the given expression whole in terms of sine. So that will be sine of 90 degrees minus 38 degrees into sine of 90 degrees minus 52 degrees whole minus sine of 38 degrees into sine of 52 degrees, which is equal to sine of 90 degrees minus 38 degrees is nothing but 52 degrees into sine of 90 degrees minus 52 degrees is nothing but sine 38 degrees minus sine 38 degrees into sine 52 degrees can be written as sine 52 degrees into sine 38 degrees. As it is a difference of same quantities, the difference will be equal to 0, and which is nothing but our right hand side. So here as LHS is equal to RHS, we can say cos 38 degrees into cos 52 degrees minus sine 38 degrees into sine 52 degrees is equal to 0. Now moving on to the third problem. If tan 2a is equal to cot of a minus 18 degrees, where 2a is an acute angle, find the value of a. Now moving on to the solution. He has given that tan 2a is equal to cot of a minus 18 degrees, as on both sides of equality, the left hand side is in terms of tan and right hand side is in terms of cot. So let us express both right hand side term and left hand side term in terms of tan, so that simplification could be easy. This can be done using the formula tan a is equal to cot of 90 minus a, or cot a is equal to tan of 90 minus a. So this will becomes tan 2a is equal to cot of a minus 18 degrees. So that will be equal to, let us express cot in terms of tan, that will be 90 degrees minus a minus 18 degrees. As we have same trigonometric ratio on both left hand side and right hand side, we can equate the angle inside it, that is 2a is equal to 90 degrees minus a minus 18 degrees, which implies 2a is equal to 90 degrees minus a, and minus into minus is plus 18 degrees, which implies, now let's transpose minus a to left hand side, then it becomes 2a plus a is equal to 90 degrees plus 18 degrees is nothing but 188 degrees, which implies 2a plus 3a is nothing but 3a, which will be equal to degrees. That implies a is equal to 108 degrees by 3, and here 3 goes in 108 36 times. So finally we got the value of a as 36 degrees. That is a solution. Now moving on to the fourth question. If tan a is equal to cot b, prove that a plus b is equal to 90 degrees. So let us move on to the solution. He has given an equation with tan a is equal to cot b, as on left hand side and right hand side we don't have the common trigonometric ratio. Let us convert the left hand side and right hand side into the common trigonometric ratio so that the simplification can be made easier. So, in order to convert the right hand side in terms of tan, we have a formula that tan of 90 degrees minus A is nothing but cot A. So, by using this, we can write tan A is equal to, cot can be expressed in terms of tan as tan of, instead of A, here we have B, so that will be 90 degrees minus B. So as on left hand side and right hand side we have the same trigonometric ratio of an angle, we can equate the angle, so that will be A is equal to 90 degrees minus B, which implies, now let us transpose minus B to left hand side, we get A plus B is equal to 90 degrees, which is the required proof. Moving on to the fifth question. If secant 4a is equal to cosecant a minus 20 degrees, where 4a is an acute angle, find the value of a. So now let us solve for the question. The given equation is that secant 4a is equal to cosecant a minus 20 degrees. Here, as on left hand side and right hand side, we don't have the common trigonometric ratio, we can't equate the angles. If we have common trigonometric ratio on both left hand side and right hand side, we can equate the included angle within the trigonometric ratio. So, in order to convert secant or cosecant into the single trigonometric ratio, that is either secant or cosecant, we have the formula secant of 90 degrees minus A is equal to cosecant A, or cosecant of 90 degrees minus A is equal to secant A. Now let us convert the given equation in terms of secant so that calculation can be made simpler. So let on left hand side secant 4a remain common, and cosecant A minus 20 degrees can be written as secant of 90 degrees minus of A minus 20 degrees, which implies, as secant is common, the included angle within the trigonometric ratio can be equated, that is 4a is equal to 90 degrees minus A minus 20 degrees, which implies 4a can be equal to 90 degrees minus A, and minus into minus is plus here, 20 degrees. That implies, let us transpose minus A to left hand side, that becomes 4a plus A is equal to 90 degrees plus 20 degrees. Now 4a plus A is nothing but 5a, which will be equal to 90 degrees plus 20 degrees is nothing but 110 degrees. That implies, by transposing 5 onto right hand side, we get A is equal to 110 degrees by 5, and here 5 goes in 110 22 times. So finally we got A is equal to 22 degrees, which is the required solution for us. Moving on to the sixth question. If A, B and C are the interior angles of triangle ABC, then show that sin B plus C by 2 is equal to cos A. Now moving on to the solution. If A, B, C are angles of triangle, then we have a condition that sum of angles of triangle is equal to 180 degrees. That implies, here A plus B plus C can be equated to 180 degrees, which implies A plus B plus C is equal to 180 degrees. Let it remain as it is. So he asked us to prove that sin B plus C by 2 is equal to cos A by 2. So now in order to prove that, let us consider the left hand side, that is sine b plus c by 2, that will be equal to sine of, here in the numerator let us add a and subtract a from b plus c, then it will be a plus b plus c minus a by 2. So we don't get any change in the value, that is b plus c by 2, which will be equal to sine of a plus b plus c is 180 degrees from the above proof minus a by 2, that will be equal to sine of 180 degrees minus a by 2 can be written as sine of 180 degrees by 2 minus a by 2, which is equal to sine of 90 degrees minus a by 2. We know that sine of 90 degrees minus theta is nothing but cos theta, that is cos a by 2, which is nothing but RHS. So here we got right hand side is equal to left hand side. So if ABC are angles of triangle, then sine of b plus c by 2 will be equal to cos of a by 2. Moving on to the 7th question, express sine 67 degrees plus cos 75 degrees in terms of trigonometric ratios of angles between 0 degrees and 45 degrees. Now moving on to the solution. Let us note down the given expression, that is sine 67 degrees plus cos 75 degrees. In order to express these two angles, that is 67 degrees and 75 degrees, in the range of 0 degrees and 45 degrees, let us apply the formulas that sine of 90 degrees minus a is nothing but cos a, and cos of 90 degrees minus a is nothing but sin a. So now expression becomes sine, let us convert into cos, that is becomes 90 degrees minus 67 degrees, plus cos, let us convert it into sine, that becomes 90 degrees minus 75 degrees. So now that becomes cos of 90 degrees minus 67 degrees is nothing but 23 degrees, plus sine of 90 degrees minus 75 degrees is nothing but 15 degrees. Now it is expressed in the angles from 0 to 45 degrees.